Rahim. In this lecture, we are going to study the compact trigonometric series, which is basically a derivation from the trigonometric series. Now we know that in trigonometric series or in a trigonometric Fourier series expansion, the signal x of t was represented as, for example, if we have a function or a signal x of t, then in terms of trigonometric Fourier series, it was represented as a naught, where a naught was the DC or the average value of the signal, and we have infinite number of sine terms, infinite number of cosine terms, and also infinite number of sine terms. Where here the omega naught is the fundamental frequency. So this was the general representation of the trigonometric expansion. We studied earlier that we have two types of Fourier series expansion. One is the trigonometric expansion, another is the exponential expansion. So this is actually the trigonometric representation of the Fourier series. Now from this is my DC signal, and these are my infinite number of cosine and sine terms. Now if we have a periodic signal, which is again, for example, g of t or x of t, let us suppose we have a periodic signal that is g of t. Now for example, that periodic signal is real, then the trigonometric Fourier coefficients will also going to be real. Now to find the compact trigonometric series representation, we are going to say that a n cosine of n omega naught, which is 2 pi f naught t, plus bn into sine of again n into 2 pi f naught t, where 2 pi f naught is the omega naught. This is going to be equal to cn. So c is my another coefficient. This is going to be equal cn into cosine n into again omega naught, which is 2 pi f naught t, plus into theta of n. So this is the compact representation. I can substitute this in place of this. So in place of this, I can substitute this over here. Also I can find the coefficient cn by equating that cn is equal to an whole square plus this bn whole square, and this theta of n is going to be equal to tangent inverse minus the coefficient bn divided by the coefficient an. So let me name it as equation 2, this is my equation 3, and this is my equation 1. And finally the c naught is going to be equal to the a naught, which is going to be the DC value. So by substituting these values, we can convert a trigonometric series into a compact trigonometric series representation. So now this was my trigonometric series representation. Now I am going to write the compact trigonometric series representation. So that can be written as g of t is equal to, because we now have the coefficient c, so we are going to have c naught is going to be the DC value, and we are going to have again n is equal to 1 up to infinite, because again we are going to have infinite number of terms. This time we are going to have cn, where this cn is equal to an whole square plus bn whole square under root, and then we are going to have the cosine function, and then we are going to have n into omega naught, which is actually the 2 pi f naught t plus theta n. So this is my, let me name it as equation 5. So this is my general representation of compact trigonometric series expansion, where this t is going to be in between the t and t1 plus t naught. So this equation is my compact trigonometric series representation. Now we are going to do an example, which is example 2.7 in the book. So we are asked to find the compact trigonometric series representation of e power minus t by 2. So what we are going to do is that first we are going to find the trigonometric series expansion of this signal, and then we are going to move towards the compact trigonometric series representation of this function. So first of all, because we are given the time period, which is 0 to pi, so it means that, let me write over here, so this is my solution. So we have the time period, that is t naught, and that is equal to 0 to pi. So the time period is equal to pi, which means that omega naught, which is equal to 2 pi divided by t naught, is going to be equal to 2 pi divided by pi is equal to 2 radian per second. So the omega naught, which is the angular frequency, is find out to be 2 radian per second. And then the fundamental frequency, or the f naught, is going to be equal to 1 by t naught, and that is going to be 1 by pi. Now let me write the general representation of the trigonometric series. Let this be my function g of t. You can name it as g of t or x of t. So let me name it as g of t. So if I represent this in terms of trigonometric series representation, this is going to be equal to g naught is equal to a naught plus summation n is equal to 1 up to infinity a n cos omega naught t plus bn sine omega naught t. This is the general representation of the trigonometric series, and we have explained this representation over here. This is the same representation. I have combined this summation under the single category. So now what we are going to do is that we are going to replace the value of omega naught in this equation. So then this equation is going to be equal to g of t equal to a naught plus summation n is equal to 1 up to infinity a n cos, we are going to have n omega naught t, and we are going to have here we are going to have n omega naught t, and we are also going to have n omega naught t over here. I forgot the n, please replace it over here. So this will be, because omega naught is going to be equal to 2, so this will be equal to cos 2nt plus bn into sine 2nt. Here this bn and an are the coefficients. So this is my general representation. Let me name it as equation 1. First of all, let me find the DC value, or the average value, which is the a naught. To find the average value, we need to take the integration of the signal over the time period and then divide the signal by the time period. So now in this case the time period is equal to pi, as I have found out over here that the time period is equal to pi, because we are going to find it from 0 to pi. So it means that a naught is going to be equal to 1 by pi integration of gt into dt over the period of pi, that is 0 to pi. So let me write as 0 to pi. So we need to solve this integration. We need to replace the g of t by e power minus t by 2. So we are going to have a naught is equal to 1 by pi integration of e power minus t by 2 dt, and the integration is going to be from 0 to pi. So now we need to solve this. We know that e power minus t by 2 integration is e power minus t by 2 divided by minus 1 by 2. It will be equal to a naught is equal to 1 by pi, and this will be equal to e power minus t by 2 divided by minus 1 by 2. And this integration interval is going to be equal to 0 to pi. It means that a naught is going to be equal to, when this comes around here, this will be minus 2 by pi, and this will be e power minus t by 2 pi to 0. So a naught is going to be equal to minus 2 by pi e power minus pi by 2 minus e power minus 0. It means that a naught is going to be equal to minus 2 by pi e power minus pi by 2 is 0.27, e power minus 0 is 1, so this will be 0 minus 1, and when you solve it you are going to get 0.504. So a naught is equal to 0.504. so we have find the DC, or the average value. Next is to find the coefficient an. So we are going to find an over here. Again, we know the formula for finding the coefficient an. that is equal to 2 by t naught integration of the time period, the function g of t, multiply by cos n omega naught t dt. So now we are going to substitute values over here. So an is going to be equal to 2 by, because the time period is equal to pi, and we are going to have integration of pi. The function is e power minus t by 2, and omega we know that in this case is 2 radian per second. So we are going to have 2n t dt. Let me name it as equation A. Now we are going to use one formula. The formula we are going to use is that, if you remember from your FSCs, that integration of e power at cosine of dt dt, and this was equal to e power at divided by a square plus b square into a cosine dt plus b sine of dt. So we are going to use this formula over here. In this case we have a is equal to minus 1 by 2. So in this case we have a is equal to minus 1 by 2, b is equal to 2 over here, b is equal to 2n over here. Fine. So we are going to use this formula. So this is our e power at cos bt dt, and this can be find out using this equation. So we are going to have an is equal to, we are going to write the 2 by pi as it is, and then we are going to say that this integration is equal to e power minus t by 2, because a is minus 1 by 2, a square plus b square. A is minus 1 by 2, so a square is 1 by 4, and then we have b square which is 2n, so that is 4n square. And then we have this term, so we are going to write a into cosine bt. A is again our minus 1 by 2, and then we have cosine b is equal to 2n, so this will be 2nt, and then again b is 2n, so this will be sine 2nt. So we have taken out the integration, and this way ranges from 0 to pi. So we can write this as an is equal to 2 by pi, and this is going to be equal to, again this will be 1 plus 16n square divided by, let me write it over here, this will be 1 plus 16n square divided by 4. So this divided by 4 is going to come here, so this will be 2 by 4, and then we have e power minus t by 2 multiplied by this thing, so this will be minus 1 by 2 e power minus t by 2, e power minus t by 2 is multiplied with this thing, so this will be cos into 2nt. So this is my one of the terms, and then I have the other term also, so that will also be multiplied by e power minus t by 2, and that will be, I am going to write 2 over here and n over here and sine 2nt, and this is going to vary from pi to 0. Okay, so let me arrange it a bit. I can say an is equal to 2 divided by 1 plus 16n square multiplied by 4 by pi, and then I can write this again, minus 1 by 2 e power minus t by 2 cosine of 2nt plus 2 into e power minus t by 2 into n into sine of 2nt, and this will range from pi to 0. Okay, let me multiply this 4 by pi into this. Let me multiply this 4 by pi into this. So I can write over here an is equal to 2 divided by 1 plus 16 n square, and when this is multiplied around here and this 4 by pi is multiplied, so this we are going to get minus 2 by pi. This is minus 2 by pi e power minus t by 2 cosine of 2 n t, and then again this is going to be multiplied by this, so this is going to be 8 by pi e power minus t by 2, and we also have n over here, so let me write n here, and then we are going to have sine 2n t, and this is going to range from pi to 0. Okay, now we now need to substitute the pi and 0. Now I want you to understand something. We have sine 2n t. We know that sine 2 pi 2n pi is equal to 0. We know that the integration is from pi, the range of values from pi to 0. So 2n pi is equal to 0. We know that sine 2n pi is equal to 0. We also know that sine 0 is equal to 0. So if I substitute pi over here, we are going to have sine 2n pi, which is equal to 0. And then if I substitute 0 over here, that will also be 0. So it means that this whole term is going to be equal to 0. So we are going to be left with this term only. So I can write it again. I can write it as an is equal to 1 plus 16n square, and we have minus 2 by pi e power minus t by 2 cosine of 2 nt, and we have pi and 0. So let me substitute these values, this pi and this 0. We are going to have 2 divided by 1 plus 16 n square. First of all, we need to substitute pi, so this will be minus 2 by minus 2 divided by pi into e power minus pi by 2 cos 2n pi minus e power minus 0 into cos 0. Now e power minus 0 cos 0 is equal to 1. We know that, so I can substitute 1 around here. So this will be equal to an is equal to 2 divided by 1 plus 16n square minus 2 by pi. Now cos n pi is equal to 1. Cos 2n pi is equal to 1. So this term equals to 1. So it means that I only have e power minus pi by 2. So now we are going to solve this. An is going to be equal to 2 divided by 1 plus 16n square into minus 2 divided by pi into e power minus pi by 2, which is 0.207. Pi is 3.14. Now if you solve this, you are going to get an is equal to 2 divided by 1 plus 16 n square into 0.504. So we have solved an coefficient, and that was equal to an is equal to 2 divided by 1 plus 16 n square into 0.504. So let me name it as equation 6. So now we have solved the a naught, which was 0.504, and then we have solved the an. You can also solve the bn. Bn is equal to 2 by the time period, which is pi, integration of pi, and then we have the function e power minus 2 by t, and then we have the sine function, which is sine of 2nt dt. Now if you solve this, you are going to get, I'm going to write it directly, you are going to get bn is equal to 0.504 8n divided by 1 plus 16n square. Let me name it as equation 7. So with the help of with the help of a naught, an and bn, we are positioned to find the trigonometric representation of a function. So now we can write the trigonometric representation of a function. So let me write the trigonometric representation of a function. So it means that g of t is equal to 0.504 plus the an, which is equal to this thing, which is equal to 1 plus 16n square into 0.504 cosine of 2nt, and summation of this is going to be from 1 to infinity. So this will be from 1 to infinity, and then we have the bn, and that summation will also be from 1 to infinity, and that will be equal to 8n divided by 1 plus 16n square into the 0.504, that will be equal to sine into 2nt. In fact, this will be 4n, not 8n. So this will be 4n. So 4n divided by 1 point, if we find over here, we have found over here, I think. This will be 8n, sorry. So this will be 8n. Now this is our trigonometric Fourier expansion. So now we have to convert this into a compact trigonometric Fourier expansion. Now here we have the a naught is equal to 0.504. We have found out the an, which is equal to 0.504 into 2 into 1 plus 16n square. This is my an, and bn is equal to 8n divided by 1 plus 16n square into 0.504. So now to represent it in compact form, first of all, c naught is equal to a naught, which is equal to 0.504. Let me name it as equation 8. And then after c naught, I have cn, and cn is equal to an square plus bn square. An is my this thing, and bn is my this thing. So we have 0.504 and 0.504. They both will be multiplied, and when the under root is taken, they will come out of this under root. So we are going to have cn is equal to 0.504 an square, which is 2 1 by 16n square. So 2 square is 4. So I am going to write 4 divided by 1 plus 16n square into whole square. And then we have this square, which is 64n square. 8n square is 64n square, and we are going to again have 1 plus 16n square square. And this is under root. So cn is going to be equal to 0.504, and because the base is same, so we can write this as 4 plus 64n square divided by 1 plus 16n square into whole square. Now cn is going to be equal to 0.504. We are going to take 4 common from this, so this will be 4 1 plus 16n square, and we have 1 plus 16n square whole square here at the denominator. So this will be cut with this. We are going to have cn is equal to 0.504 into 2 divided by 1 plus 16n square. Let me name it as equation 9. Also this 2 and 1 plus 16n square is going to be in under root. So this will actually be cn is equal to 0.504 under root 2 into 1 plus 16n square. So let me name this as equation 9. So now we have find the cn and we have find the c naught. Next is to find the delta n. So delta n is equal to tangent inverse minus bn divided by an. It means that we are going to have, we know what bn is and what an is. This is my bn, and this is my, where is an? This is my an. So if I divide this with this, 1 plus 16n square will be cut, and 0.504 will also be cut. We are going to be left with 4n. bn by an is going to be equal to 4n. So this will be equal to tangent inverse into minus 4n, which is equal to minus tangent inverse into 4n by the definition of tangent function. So let me name it as equation 10. Now we are all good to go. Now we need to just substitute in the compact trigonometric series, and we are going to find out the compact trigonometric representation. So this will be equal to g of t is equal to c naught. C naught is 0.504, and then we have the cn. The cn is 0.504, and that will be equal to summation n is equal to 1 up to infinite 1 plus 16n square into cosine. This is multiplied over here. Let me into cosine of 2nt minus tangent inverse for n. So this is the compact trigonometric series representation of e power minus t by 2. Thank you.